Hey, Dr. Clark coming back at you with another Check Your Understanding video, Section 2.1. And Section 2.1 is focusing on, it looks like, autonomous first-order differential equations. You can see right here we've got an autonomous first order. And so we want to, what do we want to do? Find the equilibrium solutions, draw a phase portrait, classify the equilibriums, and then draw a solution with initial condition at 3,1. So let's start there with part A, basically find the equilibrium solutions. So equilibrium solutions are where the derivative is equal to 0. And essentially this just gives us an algebra problem. We can factor out the y. And then we can factor the quadratic y squared minus 4 into y minus 2, y plus 2. And you can see that when y is equal to 0 or 2 or negative 2, in each of those cases y equals 0, y equals 2, y equals negative 2. Those are what makes the right-hand side equal to 0, which means the derivative is 0, so that's the idea of a solution, a constant solution or an equilibrium solution. And then they want the phase portrait. So a phase portrait, we need to put the equilibria at 2, 0, and negative 2. And so these are solutions that will be basically constant solutions, right? And what if y is bigger than 2? So what if we're up here? If y is bigger than 2, let's say y is equal to, say, 10. We would have 10 what is that? 10 cubed minus 4. That's going to be a positive number. So it's going to be positive up here. So we'll just put a positive up there. And then what would happen if we were between 0 and 2? Let's say we had 1. We'd have basically 1 minus 4. That's going to be a negative number. So we are negative here. And then we could plug in a number that's between 0 and negative 2, say negative 1. So if we put negative 1 here, I think we would get basically what? Negative 1 plus 4. That's going to be positive 3. So it's positive right in this region. And then if we put in a number like, say, negative 10, if we had negative 10 cubed minus 4 times negative 10, this is going to be, that's going to be basically a negative number. So it's going to be negative down here. So we could draw little arrows. Here solutions are going up. Here solutions are going down. Here solutions are going up. Here solutions are going down. If you want to draw some solutions, well, they want us to sketch a solution with initial condition 3,1. So if the y value was 1, for example, we'd be basically starting here. You know, solutions should kind of decay down. Here solutions should go up. Here solutions should kind of go up, and here solutions would decay down. So you can kind of see what the behavior of solutions would be in this phase portrait. So part B, but let's do them in order. Part B says classify the equilibrium solutions. So at y equals 2, it looks like solutions are diverging away from 2. So this is unstable, or you could call it a source. Y equals 0. Here it looks like solutions are coming towards 0, right? So we're coming in, so that's going to be stable. Or you could call it a sink. And then y equals negative 2 is, again, unstable. Or you could call it a source. And then for part C, they want us to graph a solution with initial condition 3,1. So here's the point 3,1. And if the y value is 1, that's kind of here, solution should be decaying towards 0, right? So basically that solution should decay towards 0 in the ty axis. All right, so that is the solution to that problem. And you can put your reflection comments on your solution and give yourself a grade here on your solution. All right, we'll see you next time.